Hi guys, in this video I'm going to talk about the oscillators in SynthMaster 3. And let's start off with the basic oscillator. Basically, when you init a preset in SynthMaster, you start off with a single layer preset, which is a basic oscillator, followed by a filter. Let's turn off the filter and play around with the oscillator. By default, it plays a sine wave, but of course we can change the wave types here. The basic oscillator features just basic shapes, the sine, triangle. Let's actually use the mouse scroll wheel to hear them. Sine, triangle, square, sawtooth, pulse. When you play the pulse, you don't hear anything because this phase parameter is 0. It's the pulse width. You have to turn it on. Let's actually use the mod wheel to play with the phase parameter. And then we have some noise types, starting with the white noise, pink noise, brown, violet noise, blue noise, and we also have different sampled noises. These are carried over from SynthMaster 1. These ones are from analog synths. SH101, boom sam, and yeah, those are the noise types. And then we have single cycle waveforms. Let's play around with the factory waveforms. I just want to highlight the analog waveforms here. Under analog category, these waveforms are actually multisamples. They are sampled at different notes. These are not wavetables, single cycle waveforms, by the way. Oh, by the way, if you want, you can just create a new waveform yourself, like this. And this is the Waveform Editor. Let's play around with these line segments. This is a segmented waveform, but I can switch to freehand and draw it myself. I can even draw the spectrum. And I can also apply a spectral filter to my waveform. For instance, let's create something like a vocal filter. I'm just double clicking to add new points to the filter. By changing this 4-month shift, I'm actually changing the peak locations. I'm shifting this graph. And by playing with this peak shift, I'm changing the Y values of these peaks here. We have 1, 2, 3 different peaks. And there's also even odd harmonic mix. If I turn it to the left, it's odd harmonics. This is even harmonics. And in between, the ratio is equal. And there's an important parameter here, which is Keytrack. By default, it's at full value, 100%. So with full Keytrack, when you press a key, this filter is applied to its harmonics. But if, for instance, if I have 50% Keytrack, and let's make it 0. So by playing with this Keytrack value, you can create interesting effects. These dips are too low. Let's increase them a little bit. Let's lower the Keytrack. Let's decrease peak shift. And let's turn off the filter. So as you see, this spectral filter is really powerful. And just like the waveform shapes, for the filter shapes, you can also switch to freehand view, freehand drawing. Like I can just draw a custom curve like this. One last thing, when I have a segmented waveform here, like these are line segments, I can have different interpolation types. Like the default one is curve interpolation. So these are curves. I can also have like step. So there are no curves, but just steps. I can also have linear. I cannot change the slope. The slope is fixed. And then curve, as before. And we also have quadratic. So this is a quadratic equation, polynomial equation. can even have a cubic equation, third degree polynomial. So in linear interpolation, we have no control points. In quadratic interpolation, we have one control point between the 2 points. And in cubic, we have two control points between these 2 points. And when you're done with your waveform, you can actually save this in SynthMaster's custom format, like custom waveform. And you can also export it to wave in 8-bit, 16-bit, 24-bit, or 32-bit float formats. Let's, for instance, save this test single cycle. And another important thing, you have a custom waveform, let's say, and you save your project. Custom waveform demo. I close my project and I open my project again. And my custom waveform is here with all the data. Because SynthMaster 3 actually saved the custom waveform data within the preset itself. This is really a useful feature. But I think we have a crash. I will investigate that. The good thing about shooting videos is you can just figure out what bugs are in your software. So I like creating tutorial videos, guys, just because it also helps in debugging. Anyway, so yeah, we created a custom waveform. We also showed that. I'm just gonna be conservative and create a sawtooth waveform. Oh, okay. Again, another crash. Let's start off with an init patch and sawtooth waveform. And I will continue explaining the other basic oscillator parameters. So we have a free button here. Normally, when I press a key, the phase of the oscillator is reset to this value. But if I press free, the phase of the initial phase of the oscillator is going to be set to a random value. Why is this important? Because in analog synths, the phase is not known. It's always it's changing randomly. So by pressing the free button, we can sort of emulate that. And to emulate analog oscillators, we have another important parameter, which is the drift parameter. With a single oscillator, I cannot hear the effect clearly. But if I press two notes, no drift, I'm playing octaves and with some drift. I can also increase the drift speed. By default, it's 0.1 hertz. That's the default frequency. You can go up to 10 hertz. So low values are good to emulate analog synths, by the way. Okay, so much for drifts. Now I'm gonna move to the oscillator unison. Oscillator unison is a very important topic, and SynthMaster 3 actually has really comprehensive oscillator unison parameters. Let's first increase this voices parameter to like 8 voices. So when I increase this, as opposed to playing a single waveform, the oscillator will play 8 different waveforms. Since I have the drift, each waveform has its own drift, random drift, and the output is like this. But the thing is, we don't have any detune spread for these waveforms, but I wanna have different pitches for them, so I'm gonna increase the detune spread. I can also play with the Detune Curve. We have also other curves. For instance, I have a mixed curve here, which basically is used to change the volumes of the waves. Let's make it something like this. And we also have a pan curve, so that you can change the panning of each waveform. By default, it's just a linear curve. But of course, I wanted to increase the pan spread, so let's do that. Now I have a stereo signal, stereo oscillator. And let's play with the pan curve. Let's increase the release a little bit. Okay, so we explained the mix, the pan spread, the detune spread, and the pan curves, and also the mixed curves. Now we also have another important parameter here, which is the unison type. Basically, since we are playing multiple waveforms, we are mixing them, we might want to have different pitches for them. But when the setting is set to unison, they all have the same pitch. So they are playing basically in unison. But we can have fifths, or we can have octaves, 1 octave, 2 octaves, 3 octaves. We can also have some chords, like a major chord. Or we can have a minor chord. We have different chords here. Yeah, so these are the unison type parameters. We also have phase spread and tone spread parameters, so that we can have variations in phase and tone parameters. Oh, so regarding this tone parameter, I have to talk about the algorithms also. Oscillators in SynthMaster 3, basic oscillators, they have different algorithms. Actually, this is valid for other oscillator types as well. By default, the algorithm is low pass. Let's switch to unison first. So in the low pass mode, we have a low pass filter, spectral filter. Let me use the mod wheel to modulate this. This is actually a very sharp filter. It's not like a 12 dB or 24 dB filter, but it's like 100 dB per octave filter. It's very sharp. And we can have other types of filters as well, like a high pass. Let's have full range for this. I can have other types of spectral effects, like a bandpass filter. So for the bandpass algorithm, we have the low cut and the high cut values. And you probably noticed that when I'm playing live, here it displays the processed waveform as well. This blue waveform is the waveform that is created with the initial values, the parameter values, and when I'm playing, the performance controls like the mod wheel and the velocity are also applied. The modulation sources are also applied on top of the parameter value, and the waveform changes into this. We also have band stop algorithm. The spectral algorithms. We also have some phase distortion algorithms like the band algorithm. Let's clear this modulation and so for the band algorithm, I'm going to modulate this this knob with the mod wheel. So this is the initial value. So I'm applying some, I'm bending the waveform, I'm applying phase distortion. Let's continue with the other ones. Like we have band minus. And we also have band plus minus. By the way, these band algorithms, they will create some aliasing. So what you can do is you can go to settings, audio engine, and you can actually change the engine quality. By default, the engine quality is draft, meaning no oversampling. But if you set it to good, then you will apply 2 times oversampling. So if you are working at 44 kilohertz, for instance, the sampling rate will be 88 kilohertz internally, and then SynthMaster will downsample to 44. Now hear this without oversampling. When I max the mod wheel, I'm hearing aliasing. But with good quality, the aliasing actually decreases. So let's keep it at good quality. And let's continue with the other algorithms. We have some hard sync algorithms. we have different hard sync algorithms. The first one was no window, and also I have hard sync applied with some windows. I also have cosine window. These are all different settings. I have saw window. I have some. I have other algorithms like a pulse algorithm, pulse 1 and pulse 2. This is also a phase distortion algorithm, sort of. It changes the shape of the algorithm, a waveform. Sorry. Then we have pulse 2. This pulse 2 algorithm is actually it is similar to this pulse waveform. Basically, it subtracts the subtracts a phase delayed version of the waveform from itself. So if I change my waveform to something else, for instance, let's have a square. I also have a bit crush algorithm, which basically changes the bit depth of the waveform. At maximum value, we have the full waveform. At lower values, we decrease the bit depth. So basically, the waveform becomes a low res. The waveform bit depth becomes low res. This can be used in lo-fi presets. Okay, so much for algorithms. So we covered the algorithms, the voices. Regarding pitch. Basically, I mean, obviously you can change the pitch, the coarse pitch and the fine pitch. Now, one thing to highlight regarding the pitch is you can also set the pitch in octaves from here, or in semitones. Why this might be necessary? Because when changing the pitch with your mouse, it might be hard to get the exact pitch. In those cases, you can actually do it from here using a menu. Now I'm going to apply some pitch modulation and show something new. This was also featured in SynthMaster 2, by the way. I'm going to apply pitch modulation first. Let's no attack, just some decay. And let's go back to low pass algorithm. So it's just basic pitch modulation, nothing special here. But now I'm going to quantize this pitch. We have different scales in SynthMaster. Like for instance, let's quantize this pitch to a major to scale. see the pitch is quantized to a major scale. Let's change the slope. Let's also have some attack. So yeah, this is how you can achieve pitch quantization. Of course, we have interesting scales. So let's have, for instance, an Arabic scale. Or let's have some interesting scale. So yeah, by playing with this pitch quantization, you can get really interesting effects. Now I talked about all of the features except the sync button. To explain, this is basically hard sync, and it is similar to these sync algorithms. It is actually similar to sync no window. To demonstrate how it works, I'm going to add another. Let's start off with an init patch. And now I am going to add a new oscillator, a basic oscillator. Let's have a triangle shape. So I turned on the sync button for the second oscillator. And let's turn off the filter. Now, if I change the pitch of the second oscillator, let's actually use the mod wheel to change the pitch. Basically, the oscillator is hard synced to oscillator 1, so that whenever the phase of oscillator 1 becomes 0, the phase of oscillator 2 is also set to 0. So this is the classic hard sync effect. For the mod wheels, I just want to apply some smoothing. So I'm going to change the global MIDI-CC lag. Let's make it to 100 milliseconds. So this way, whenever SynthMaster receives a MIDI-CC, it smooths the incoming signal. And you can actually apply this at preset level or globally. I basically set it globally. Just so you know, this hard sync effect actually creates aliasing. So you'd better increase your quality to good or even upper values. Okay, so we also explained the hard sync, and next I'm going to talk about the Keytrack here. Let's continue with oscillator 1. By default, the Keytrack is at the Keytrack base note is note 60. That corresponds to C4, I believe, and the Keytrack amount is at 100%. So this Keytrack can be between 100% and minus 100%. So basically, when I go at upper octaves, I actually reverse the Keytrack, and I think we can see it from. You see, I'm going up in the keyboard, but this oscillator is rendering lower notes. So I can even have a 0 value for the key track. 64 corresponds to 0. So at 0 value, the oscillator runs at a fixed frequency. You see, I'm playing different notes, but it's basically just playing the same frequency. So let's increase this to 100% again. Here's a cool trick. Just slightly modify this key track value, like, and please press your shift key when modifying this knob value. So I changed it slightly. And let's also add some drifts. I'm playing octaves. And it sounds like an analog synth, because in analog synths, this key track amount is never 100%. So you get sounds like this. As opposed to this. This is digital version. And this is how you can achieve analog sounds with SynthMaster, by pressing the free button, increasing the drift, and also slightly lowering the key track amount. And if you increase the release, we're gonna get some lush sounds. Okay, so this is so much for the basic oscillator. Oh wait, I forgot one thing. I'm sorry. I have to explain this as well. We talked about the basic shapes, noises, and single cycle waveforms. But of course, the basic oscillator is not that basic, so that it can also play multisamples. Let's, for instance, load some plucked strings, like an acoustic guitar. We have lots of different samples. We even have samples for different strings on a guitar. This is our second guitar. And we have a bass guitar. Other instruments. Okay, we have a kanun, santur, oud, browse through this factory library. We have lots of different acoustic instruments, and we have vocals also, female and male.
Yeah, yeah, yeah.
Feel free, to browse through them. You're gonna find really interesting content. And one interesting feature in SynthMaster is you can convert different oscillator types to each other. For instance,
Ya.
I played this sample and I right click on this, I click on this menu here for oscillator 1 and I say replace with Wavetable Oscillator. And it changed this into a wavetable. The sample that I played is converted to a wavetable actually. And once you converted a sample into a wavetable, I mean, you can do really interesting stuff, which will be actually covered in our wavetable video. Guys, thank you for listening to me. And now I'm gonna explain in my next video the additive oscillators. To explain the additive oscillator, let's start with an init preset. And let's turn off the filter. And here I'm gonna click the oscillator menu and replace with additive oscillator option. So what is an additive oscillator? The additive oscillator actually features 8 different basic oscillators, so to speak. And you can edit the waveform type, the volume, pan, detune, phase, tone, and algorithm of each waveform separately. So by combining different oscillators like this in a single oscillator, I mean, you can create some really complex sounds. Let's, for instance, start with the basic sawtooth. And here on this area, you can actually change the volumes of these waveforms. Now I'm going to change the, these are the pitches of the waveforms of the additive oscillator. I am going to just make them like an organ. So for the organ, the pitches should be 1, 2, 3, 4, 6, 8, 12, and 16. We also need a 32. Let's make it 16. And if I increase the drift amount, it applies to all of these waveforms. And similarly for free running. And let's also decrease the key track slightly. And let's increase the release time. Yeah, so let's play around with the waveform shapes. Let's also choose some noise. I can also choose like a pink noise, but white noise is better. Let's, for instance, switch to a wave volume view and add modulation for the noise, velocity modulation. So basically with the velocity modulation, I'm going to have a higher noise volume with higher velocity. And I'm going to change this to pink noise. No, I can't hear it properly. Let's make it white again. I can also change the fine-tune the detune of each waveform. Let's actually make this also 1 and this also 1. So similarly, you can also play around with the phase, tone, and algorithm of each basic oscillator separately. And you can actually even load samples onto these oscillators from here. You can load samples too. So this is what the additive oscillator is about. And one last thing about the additive oscillator, you can, just like in the basic oscillator, you can convert this additive oscillator to a wavetable. This is really a nice feature. Let's replace this with a wavetable. So basically, it used, basically when converting, SynthMaster actually used the individual waveform information from the additive oscillator, including the noises, to create this wavetable. So let's modulate the index. Okay, so much for the additive oscillator, guys. Next, I'm going to move on to the vector oscillator. To explain the vector oscillator, let's first start off with an init preset and turn off the filter, and then let's replace this with a vector oscillator. So basically, the vector oscillator is 4 basic oscillators mixed in different modes. The first mode is a one-dimensional mode. So in this mode, and for mixing, we have the x-axis and the y-axis parameters. So in the one-dimensional mode, the x-axis is basically controls the mix amount between 1 and 2, and the y-dimension controls the mix between oscillator 3 and oscillator 4. And these are the frequencies of the oscillators. Let's actually make these 2, 2, 2, and these are, let's make them 1. Two-dimensional mode is more interesting because this time we have a two-dimensional control between the 4 oscillators. So this is what the vector oscillator is about. And just like the other oscillators, you can convert this oscillator to a wavetable. Okay, so this is so much for the vector oscillator. Next, I'm going to talk about the wavetable oscillator. To explain the wavetable oscillator, I am starting off with an init patch. And next, I'm turning off the filter and converting this basic oscillator to a wavetable oscillator. Okay, so now I have my wavetable oscillator here. The wavetable oscillator is actually very similar to a basic oscillator with one important difference. In the wavetable oscillator, we have a table of single cycle waveforms. And we use this index parameter to cycle through the waveforms in our wavetable. So let's go through some of the wavetables in SynthMaster's factory library. For instance, we have some pulse wavetables. And let's I can also use this random button to load a random wavetable. One important thing about this index parameter, starting with SynthMaster 3, we have a new parameter called Crossfade, and by default this is set to linear. So basically in your wavetable you can have a low number of waveforms, and SynthMaster by default crossfades between those between consecutive waveforms so that it smooths out. And in other synths like Serum, they actually don't do that. There's no crossfading. Instead, they just play the current waveform in the wavetable. So you can hear the difference. This is crossfade turned off. And this is turned on. And if I want to edit this wavetable, I just click on this pencil icon and our Wavetable Editor opens up. SynthMaster actually comes with a really comprehensive Wavetable Editor. And here you can see the frames in our wavetable source. This is actually a file source. We have different key frames. These are the individual frames of our wavetable. And by default, we have 8 frames, but actually I can increase this number of frames. Let's, for instance, increase this to 128 frames. So although the original wavetable has 8 frames, SynthMaster is rendering it as a 128 frame wavetable now. And since this is a file source, I will come to the file source types in a minute. Since this is a file source, we can apply some different blend types here. By default, it's using waveform, which means we are just crossfading between consecutive waves in our wavetable. We can also apply some spectral blends. For instance, the source phase means use the phases of the use the original phases. Now compare this with waveform. This is a lot different from this spectral blend. Spectral blends is basically smoother because it's applying spectral processing. It's processing amplitudes and phase of waveforms independently. That's why it's smoother. And for the phase settings here, we have 0 phase. And we also have another important one, first phase. So basically this first phase uses the phase information from the first waveform in our wavetable. So I would highly recommend you guys to use the spectral blend instead of a waveform blend. And of course I can normalize my wavetable. And I can remove the DC offsets. And when I'm done with my wavetable, I can save it. SynthMaster can save the wavetable in its own format, and it can also export it as a wave file. So let's save it with a new name. So now I saved it in our custom format, and next I want to import some wavetables. I have some existing wavetables and I want to import them. So let's go to my D waveforms folder, and I have lots of folders here. I'm just going to demonstrate importing from one folder, like this one, Waves Codecs. So I'm just drag and drop, and it's read the files, and it's actually loaded the first one. So the wavetables that are loaded are here under the user category. Just so you know, SynthMaster 3 did not copy the files at all. It just copied the folder path. It recorded the folder path and it added that to its list of wavetables. It didn't copy anything. But if you want, you can also copy the wavetables or waveforms or samples to your SynthMaster documents folder. That's possible. I can use these arrow keys. Yeah, we have really interesting wavetables here. Let's continue. This one's good. This one, and now I want to add some wavetable effects to this file wavetable. So here I have my keyframe view, and I'm going to add like a Waveshaper. So this Waveshaper is actually similar to our Waveshaper effect in our modules section. And here we have different start and end keyframes for our Waveshaper. And initially I have no drive, and it's just the input signal. This is the mix ratio between input and process signal. And in my final frame, I'm going to have some drive, and input and output will be mixed equally. Let's move this wavetable index to the beginning. So for the Waveshaper, we have different types of distortion curves. Let's go through them. We have heavy algorithm. So the heavy makes it like this. We also have fuzz. Let's actually make this fully wet. And next we have fold algorithm. This is sort of like an FM algorithm. The next one is similar to the fold sine, but this time it's a triangle fold. And let's continue fold round. Okay, so that was fold round. And next we have rectify. And we have half rectify. And finally we have clip. So this is how the Waveshaper works. I'm going to actually change the wavetable here. By the way, when you load a different wavetable, these effects are kept, but they are just bypassed. This is with the Waveshaper, and this is without the Waveshaper. And let's apply the Waveshaper. Nice. Now I'm going to add a second effect, Modulator. I'm going to turn off the Waveshaper to show the Modulator. Basically, we can apply ring modulation, frequency modulation, or phase modulation on the individual waves. These are the individual frames in our file source. So with the modulator, we can apply different types of modulation on the individual frames in our wavetable. So let's go through their parameters. For instance, and this waveform here is our modulator waveform. So I have a sine, triangle, square, saw up, and saw down. Let's go with sine. And this is phase modulation. I can also have ring modulation, which is basically multiplication. And for the ring modulation, I can increase the offset. And when the offset is at full value, its ring modulation becomes amplitude modulation. And for our keyframes, we can have different pitches. So at the final keyframe, for instance, let's have a different pitch. Let's also add some offset to the waveform. And in our initial keyframe, let's have no offset and equal mix between input and output. So this is ring modulation. Let's select frequency modulation. And let's also go back to phase modulation. Phase modulation is the richest in terms of harmonic content. And I'm going to increase the number of frames to 128. And for the file source, let's have first phase. Okay, I like this wavetable, so let's save it. By default, SynthMaster saves under SynthMaster 3 waveforms folder. Okay, so I will also talk about the master filter. Each wavetable in SynthMaster has a master filter, which is actually applied when creating the wavetable. This is different from a spectral filter because the spectral filter does not have a keytrack parameter, but here we have a keytrack parameter. So for the master filters, we can either draw the filter shape using line segments. We can double click to add points, or right click on a point to delete that point. Like this. And when you add new points, they are also added to other keyframes as well. But I'm just gonna go simple and draw the filter shape using freehand. So this is my initial shape. And this is going to be my final shape. Right. Okay, let's change the waveform index. So when I change this keyframe index here, as you see, the waveform here changes, and also the filter shape here changes because it shows us the waveform and filter rendered for that specific keyframe. And just like for the single cycle waveform editor, we can change the even and odd harmonic ratios. And for the initial keyframe, let's make it like this. Oh wait, I haven't turned on the master filter yet, so let's do that. So this is how the master filter, how the preset sounds with the master filter. by playing with the key track, we can actually create interesting 4-month sounds. Okay. This is without the master filter, and this is with the master filter. And this is the original file source. So aside from these Waveshapers, Modulators, and master filters, we also have other effects like the shifter, benders, lo-fi, and sync. And let's delete this effect and add, for instance, a shifter. Let's now play around with the shifter parameters and see how they work. So this X shift parameter basically shifts the x-axis, and this Y shift parameter shifts the y-axis. They can either wrap around, clip, or invert. Let's, for instance, wrap this one and invert this one. So it's gonna fold back after clipping, reaching the end. Wait, let's increase the shift amounts for the final keyframe, and also for the final keyframe I'm gonna have a full wet effect value. And for the initial keyframe, I'm going to have dry input. And by moving this keyframe indicator, I can see how the effect actually is applied to the waveform. I can also try different modes like clip and clip. So the waveform is being clipped on the x-axis. Let's also try invert and invert. Okay, so much for the shifter. Now I'm gonna delete this one and add a new one. Bender. This time I'm gonna bend the waveform. So initially I have my dry input, and in my final keyframe I have a wet signal, and it's going to be bent. And I'm also going to change the pitch to 12 semitones, 1 octave. I'm also going to change the phase. This adds some nice phase distortion. And let's see how it sounds with the master filter. It sounds like a vocal effect. Okay, so much for the bender. I'm gonna add a new one, lo-fi. As the name specifies, this applies bit reduction and also sample rate reduction. And the X grid specifies the sample rate reduction, and the Y grid specifies the bit rate reduction. Initially, let's have a dry signal, and in the output, let's have some attack and release for the X and Y grid. So this is how the lo-fi changes its input. And let's delete this one. I'm gonna show the final one, the heart sync effect. This is similar to the heart oscillator sync. And we have different window types. And in the final keyframe, I'm going to change. I'm gonna heart sync. So I can change this window. This effect is actually similar to the sync algorithms that we covered in our basic oscillators. But here we can change the length of the window applied. We also have cosine window. And we can actually increase the final pitch. And we can mix input and output, so we get the classical heart sync sound. And let's try other windows. We can have Gaussian. I mean, they're almost similar. This is different. Okay, so much for the effects, wavetable effects. I hope I covered them well. Now, I talked about file sources. We have other types of sources as well for wavetables. The next one I'm going to cover is actually samples. Yes, you can use just regular samples as file sources. And what is the difference between a wavetable and a sample? Well, actually, a wavetable is a sample with a certain length. So the length of wavetables is always a multiple of 2048 because that's our default wavetable frame length. So let's actually load, for instance, a vocal sample from our factory library. Vocal, male, ah. Let's load C3. So yeah, it sounds like an ah. Since this file has its root node information, SynthMaster actually used that root node information to find the period markers, but you can do that manually yourself as well. You just have to select a section, select a single period, and you select this menu item, detect periods around selection. And now it's fine. It uses a detection algorithm to find the corresponding periods in my file. Let's actually add some release to this guy. Yeah, it sounds nice. For the final keyframe, I'm going to change the final position to somewhere here. And initially, it starts from here. Okay, so much for the sample editors, the sample input file sources. This is how you can load a sample and find its periods and then use that to create a wavetable. Aside from file sources, we also have wave sources. So basically, wave sources are single cycle waveforms. Each keyframe is a different waveform, a single cycle waveform. Like I can double click and add new keyframes here. And then I can actually edit shapes of these keyframes. I'm just freehand drawing. This one. And finally this one. So let's go back to the first keyframe and see how it sounds. So if I want, I can actually load different waveforms from our single cycle factory library here. Let's load this one here. Let's load this one. I'm just loading randomly actually. Factory. Okay, let's see how it's gonna sound random. And let's actually change this blend to spectral and first phase. And if I apply the Waveshaper effect I created before, yeah, this is how it sounds. Now, finally, I will explain the line sources. These are also single cycle waveforms, but this time we are actually using line segments to create the single cycle waveforms. For instance, let's start off with a sine wave. And here, in the final keyframe, let's do some interesting stuff. Let's create something like a pulse. Just as in the Waveform Editor, we can double click and add new points here. And here I can edit those points in the final keyframe. Final waveform, and this is the initial one. apply the Waveshaper. And just as in the Waveform Editor, we can change the interpolation type. For instance, let's try step interpolation. So with the step interpolation, the waveform, let's turn off the Waveshaper, the waveform goes like this. You see they're all steps. And in the linear interpolation, we have just linear line segments, and in the curve interpolation, we can have a curve slope for each segment. And we also have quadratic. We have quadratic curves here. Finally, we have cubic. I'm done with editing my wavetable. I can just save it as a custom wavetable, or I can export it as a wave file, like test wavetable. I saved it as a wave file, and just as in the single cycle waveforms, when I save my project file, it's actually going to save this custom wavetable in my project file. And if I close it and reopen it, the wavetable is still here, as you see. Okay guys, so this is so much for the Wavetable Oscillator and the Wavetable Editor. Next, I'm going to talk about the virtual analog VAnalog oscillators. To explain virtual analog oscillators, let's start off with an init patch, and then replace this with an VAnalog oscillator. So, virtual analog oscillators are new in SynthMaster 3. We didn't have them before for SynthMaster 2 or SynthMaster 1. Basically, virtual analog oscillators use a different type of synthesis, different type of rendering to render oscillator waveforms. They actually use line segments that we showed in our basic and wavetable oscillator videos. We use line segments to create waveform shapes, and we can, with the VAnalog oscillator, we actually do that in real time. So we have two line segments, and using those line segments, we create the oscillator shapes. So this is how my shape looks like. And we have two shapes actually, the initial waveform and the final waveform. Let's edit the final waveform actually. Let's, for instance, make it something like this. Let's turn it into a pulse waveform. And we have two different parameters here, x morph and y morph. Basically, we use them to morph the lengths. We use the x morph parameter to morph the lengths of segments from 1 to 2. And we use the y morph parameter here to morph the initial and final values and also slopes. So if I use the mod wheel to modulate these morph parameters, I'm going to turn off the filter. One important fact about the VAnalog oscillator: these oscillators generate aliasing. Just beware of that fact. And because of that, we have this quality setting. By default, the quality is low, meaning that the oscillators run at regular sample rate. But you can increase the sample rate. Normal means 2 times oversampling, high means 3 times oversampling, and best means 4 times oversampling. I'm going to work with normal because here on my audio engine settings, I also set the engine quality to good, which is actually 2 times oversampling. So normal should be a decent setting for me. Here I also have a symmetry setting. So basically this changes the ratio of the length of the first segment to the second segment. So you can create really nice, you can quickly create pulse width modulation type of stuff. Like this. Let's, for instance, modulate this with velocity. So why did we need this oscillator type? Well, first of all, for the basic oscillators, they're based on single cycle waveforms whose lengths are 2048 samples, and that actually corresponds to the note F0, I guess, or F1. And at low octaves, I mean, they have a low resolution. So if you are creating, for instance, analog bass sounds, I highly recommend using virtual analog instead of the basic oscillators. And you can create similar shapes and morph between them, of course, using the Wavetable Oscillator. But the Wavetable Oscillator has fixed number of frames. So because of that, you can hear you can hear a stepping sound when going in between frames. But here in the VAnalog Oscillator, it's smoother, so you will not notice any stepping sound when morphing between two waveforms. So basically, I can slowly morph between two waveforms without hearing any stepping sounds. And of course, we added lots of, we analyzed lots of analog waveforms, and we added some virtual analog oscillator presets. They are actually here. Oh no, here, sorry. Let's load a preset. For instance, Andromeda Pulse. Let's clear this modulation. Oh, it's actually cleared. Let's, for instance, add mod wheel modulation and see how the Andromeda Pulse shape is. Now I'm gonna add unison to the sound. 3 voices. Let's add some drift, and also let's lower the keytrack amount a little bit. Let's increase this and add detune spread, and pan spread, and add some mixed curve, and add some pan curve. Of course, we have other shapes from other synths. Let's go through them. Oh, by the way, if I move my mouse over this menu here, over this icon, and if I use my mouse scroll wheel, I can actually cycle through these presets. So instead of choosing each one by one, I can just cycle through them. This is, for instance, base station pulse waveform. Let's see how it sounds. Let's continue with other shapes. Base station pulse, base station triangle. Oh wait, MS20 pulse. Yeah, let's try this one, MS20 pulse. So yeah, as you see, we have lots of different waveforms here to choose from. Like we can also select OB6 pulse and see how it sounds. As you see, these pulse waveforms all sound similar, but they have their own character. So I believe it's better to represent them in this way, in this method, using these line segments. And finally, about the virtual analog oscillator, I'm going to show you how to convert this oscillator into a wavetable. This is also a handy feature. So I can just replace this with a wavetable oscillator, and as you see, it is now converted to a wavetable. And this is my virtual analog VAnalog oscillator as a wavetable, in wavetable form. So as you see, we have these 2 line segments morphing from one to the other one, but this time we have a fixed number of frames. But of course, if you convert it to a wavetable, you can apply wavetable effects or these oscillator algorithms. I mean, you can do all of those. But I can clearly hear the stepping sound. Maybe to minimize that, I can what I can do is I can convert this to a wave source, or I can render the entire wavetable as a file source. Okay, so now I have a wavetable with a file source. This is my wavetable converted in. This is my virtual analog shape or waveform converted to a 64 frame wavetable, and now I'm going to use spectral blend, and let's see how it sounds. There's a noise somewhere, I don't know why, but I will look into it. So this is basically how you can convert a virtual analog oscillator into a wavetable oscillator, and this is so much for the virtual analog oscillator I'm going to talk about. And next I'm going to talk about the modulators. To explain the modulators, I start off with an init patch, and then I move to the routing view, turn off filter 1, and I add a new modulator. So basically, this modulator is like identical to an oscillator, as you see. But there are some differences. For the oscillators, we have voices, but for the modulator, we don't. Because a modulator is a single oscillator. It doesn't have oscillator unison, and it works as a basic oscillator, and its output is mono. Compared to the oscillators and filters and waveshapers, they have stereo output. These are all stereo outputs. But this modulator has a mono output. You can think of the mono modulator as an LFO running at audio rate. And using the modulator, you can modulate phase, frequency, and also the amplitude of oscillators. For instance, let's try phase modulation using by connecting this modulator to the oscillator. When the volume of the modulator is at 0, this is how my oscillator sounds. But if I increase the volume of the modulator, this is how the phase modulation affects the oscillator. I am just going to add a new envelope to change the volume of the modulator here. Let's add some decay to the envelope. Let's have a long envelope actually. Let's also increase the release of the volume envelope. Since this is a basic oscillator, I can actually change its shape. Let's, for instance, choose a basic waveform. Let's choose an analog waveform, like this one. Let's cycle through the waveforms. To add a second modulator to this modulation entry. I'm going to add a via source, which is a mod wheel. So basically, I am going to control the volume of this envelope with the mod wheel. Right now, there's no modulation applied. I'm going to decrease the release. Let's continue choosing different waveforms for the modulator. Speaking of FM, the modulators can actually be fed back to themselves. To do that, just connect this output of the modulator to its input. So when it is fed back to itself, I see this line around it. And this feedback amount controls how much feedback is applied. I'm actually going to remove this mod wheel. And I'm going to apply the mod wheel to this feedback parameter and see how it changes the sound. So far we have covered phase modulation, which is Yamaha DX7 style FM synthesis. But we can also do frequency modulation. When doing frequency modulation, just increase this offset value to its maximum. Let's choose a sine wave. Let's clear the feedback. So this is, let's clear this feedback. This is FM. And wait, let's connect this again. And this is phase modulation, PM. They're somehow similar. I know one is the derivative of the other one, but I don't know which one. But they sound like this. Let's right click and set it to FM. You can even have noise, for instance, as a modulation source. And you can change the pitch actually. Sounds like FM. I'm going to change this to phase modulation. I can, of course, add new oscillators and add new modulators. And let's connect this one to oscillator 2. And I'm going to control click to select the corresponding module. This is how you can change between modules. Control click on the module. So let's go to modulator 2 and change actually its pitch. Let's make it 1 octave lower. Actually created a 4-operator FM, and this envelope I'm going to apply it to this modulator as well. Okay, so we covered frequency modulation and phase modulation, and we also have amplitude modulation. So I'm going to connect the modulator to the second input of the oscillator, And I'm going to set the type of this input to multiply. Multiply means amplitude or ring modulation. Let's turn on modulator 2. Oh, I mean modulator 1. Sorry, it's already turned on. Wait, why don't I hear anything? Let's start off with an init patch, and I'm gonna try again. I'm gonna add in a modulator and connect it here. Oh yeah, now it's working. Set type to multiply. Yeah, it's working. This is amplitude modulation basically. Basically, you multiply two signals together. So this is, oh wait, there's one more thing about the modulators. Since this is a basic oscillator, of course, you can also load samples on the modulators here. Let us, for instance, load a vocal, like a female ah. Guys, I have to check this one. Somehow I'm not hearing. Maybe the modulation is not strong enough. Yeah, it's somehow modulating, but I have to double check this. Anyhow, so this is so much for the modulators, and I think we covered all of the oscillators section here. And next we are going to move on to the filters in our next video.